Welcome to 10C Unit 3 Trigonometry Review. So the first thing we need to know about trigonometry is we're dealing with right triangles for acute trigonometry. So we do notice they have to have a right triangle in order to use the trig functions. One of the basic trig functions we've learned many years in a row now is the Pythagorean theorem. And that's used to find unknown sides. So one of the Pythagorean theorems is a squared plus b squared is equal to c squared. This would be c, this is b, and this is a. Now, c is always called the hypotenuse. And it's also the longest side. Because of that, if we are trying to solve a triangle with two of the sides, we need to understand, are we solving for a short side or are we solving for the longest side? The ones on the left of the equation, A and B, these are the two short sides. And they're attached to the right angle, the 90-degree angle. So if we need to solve for the long side instead of a short side, we need to rearrange this equation because the Pythagorean theorem, originally this equation solves for your hypotenuse, solves for the longest side. So to rearrange it to solve for a short side, we subtract one of the variables to the other side. So we would get c squared then would be equal to, b squared. A or b squared, it doesn't matter which short side you use, a squared or b squared, is equal to your longest side, c squared, subtracted to the other short side. So in this case it would be b squared, in the next case it would be a squared. And of course, in our final answer, we're not looking for a squared or b squared or c squared, we're looking for the individual side. So in order to get rid of that square root, that squared sign, I need to square root my final answer. For example, for a right triangle with sides 6 and 8, I need to find x, the longest side, the hypotenuse. So in this case, I'm going to take the x, and it's the longest side that I'm solving for. So I'm going to take these two shortest sides and I'm going to add their squares. So 6 squared plus 8 squared should be give me my c squared in this case, which is my x squared. So I'm going to solve each separately according to BEDMAS. In your calculator, it might do the BEDMAS for you. So 6 squared is 36, 8 squared is 64, and again, we add them. And we're going to get exactly 100. So that is equal to then c squared, our longest side. I don't want c squared, I want c. So in order to get rid of that squared sign, I'm going to do the opposite function. And that cancels the squared sign out. So my squared sign's gone there, and it's also taken out my square root sign. So I need to do the same to both sides. So I square root the 100. That gives me my c is equal to 10. So now I know my longest side, x, is equal to 10. It doesn't matter which variable you use, a, b, c. It usually depends on what the problem-solving question gives you. The next example is going to be talking about solving a short side. So if I've got a triangle like this, the next example here, and I've got a 5 on that side, and I've got a 3 over here, and I need to solve for x. Well, when I take a look at that diagram, I need to realize that the 5 is the longest side because it's across from the right angle, and he's the diagonal line. Okay, that's how we find the longest side. He's always across from the 90-degree angle. So this time, since I'm finding a short side, I'm trying to find a short side, I need to reverse my equation and rearrange it. So this is when I take my c squared and I subtract one of my other sides. And that's going to give you your a squared. Now again, a and b can switch places. It really doesn't matter who is who. The fact of the matter is you need to understand that c is the longest side. Okay, in this case I would get 5 squared minus 3 squared would give me a squared. In this case, x squared. That's going to give me 25 and 9. And according to BEDMAS, I had to square them first, then subtract their answers. And again, that's going to give me a squared. So I'm going to get a total of 16 for a squared. And again now, I need to be able to square root the answer to solve for a. Square root your a squared. A is equal to, oh, pardon me, 8, goodness me, 4. A squared, the square root of 16 is equal to 4. So, now I know the length of my shortest side. Let's take a look now at our other 3 trig ratios. So this is our basic trig, just finding sides when we're only given 2 other sides in the triangle with no angles except for the 90-degree angle. Okay? So if you ever have the situation where you've got 2 sides and a 90-degree angle and you don't know the other 2 acute angles, the other 2 acute angles are these 2. If you don't know those 2, you can't solve for an unknown side using the trig ratios. You must use Pythagorean theorem. So we're going to take a look at our first trig ratio. But in order to do that, we need to understand how we're going to rename the sides of our triangle. So now our right triangle, instead of becoming A, B, and C, C leg is still our longest side. But now our longest side gets a new name. We call it the hypotenuse. The other 2 sides are just our short sides. They're called the legs. The legs are attached to the 90-degree symbol. Okay? That 90-degree angle there. So, when we find our triangles, we need to be able to label our triangle according to what our angle is. So, for example, if I were to draw a different triangle for us, we need to be able to label each of the parts. So now there's my 90. I know that's my hypotenuse. There's my H. Well, I've got 2 other sides, but I'm not able to identify them unless I circle an angle. So let's say I'm finding angle theta there. If I want to find angle theta, I need to be able to write my equation. So let's say I give myself, not write my equation, pardon me, I need to identify the sides attached to it. So I know that these 2 are legs. But which legs are they? Well, we get 2 new names. Instead of being called leg and leg, they can be called opposite and adjacent. Opposite means, just like the hypotenuse, it's across from the angle. So across from this angle would be called the opposite side. The opposite side gets the symbol O. The side that is left over between the 2 angles, between your acute angle theta and the 90-degree angle, this side here is now called your adjacent side. And we label it with an A. So here's the adjacent. And what basically adjacent means is it means beside. So the adjacent leg is beside and touching the angle and the 90-degree angle. Okay, so both angles it's touching. Now, one of the properties we need to remember as well about triangles is that they all add up to 180 degrees. So the minute I put in, if this was A and this was B, the minute I put a degree symbol in there and I say, okay, well this is going to be 42 degrees. I need to be able to find out what angle B is. Well, in order to find out a missing angle, if you know 2 of them, you would take 180 degrees and subtract the other 2 angles. And that finds you the 3rd angle all by itself. So, I'm going to subtract my 90 degrees, and I'm going to subtract the 42 degrees. That's going to give me 48 degrees. So that way, I know angle B now has to be 48 degrees. Another way to do it is if you understand the property of triangles, that they all must add up to 180 degrees no matter what. And if you understand that 90 is exactly half of 180, that means that this is 90 and the other two must add to 90. So instead of doing this step here, all I need to do is take my 90, subtract my 42. And that will find me my other answer for my missing angle. Okay, now we know how to label our legs. Let's take a look at a couple examples you have in your review questions. So example 1, you've got the triangle ABC, 63 degrees is angle A, 13 centimeters is the side between BC, and you want to find X. So again, the first thing you need to do in order to label your legs is you need to be able to circle the angle they give you. Now, you're not going to ever circle the 90 degrees. That's a given in a right triangle. You're going to circle one of the acute angles. In this case, that's going to be angle A or angle C. Well, they didn't give me a number at angle C. Yes, I can find it, but they did give me an angle in angle A. So I need to circle that angle. Now I'm going to label all of those other sides of my triangle according to that angle. So that means the side that is across from him is going to be called our opposite side. The side that's attached to him and between the 90 degrees and that other angle is going to be called the adjacent side. And of course, our last side across from the 90-degree angle is your hypotenuse. It never changes. All right, so the first part says, which is the opposite side? Now we can call it this way. When we name triangles, we can name each side with 2 letters, or we could name it with the small lowercase letter of the angle across from it. For example, what that means is the 13 centimeters is the opposite side. So A wants to know what the opposite side is equal to. Well, we could name it as baby A, side baby A, or side B to C, okay? Meaning that it's between angle B and angle C. That's what that means for us. So again, we can use it by taking the angle and using the lowercase angle, the lowercase letter for the angle. So angle A across from him is my opposite, so that's also called baby side A or BC. So let's take a look at the second one. I want the adjacent side. Our adjacent side we've already labeled A. Well, if I take a look at the angle across from him, the angle across from A is the C. So that would be baby C in this case. So I could call him lowercase c, or the 2 angles that the side is between. Well, that side is between angles A and B. So we could call it also side AB. Lastly, we have the third option, which is hypotenuse. Well, the hypotenuse is always across from the right angle. So we do have our hypotenuse labeled. So since we have a right angle, we take a look at what the angle is named on that right angle. It's a B. So I go across, and that side, yes, it's called X that we're solving, but it's actually named lowercase b, or the 2 angles it's in between A and C. So side AC. Okay? So there's many different ways to name those angles and those sides according to the angles. Let's take a look at, you can try B yourself. Let's take a look at number 2. If we want to solve right triangles, well, if we need to solve the triangle for all unknown sides and angles, we need to be able to understand the trig ratios. So here comes our 3 trig ratios. First one, we're first going to write our SOHCAHTOA. SOHCAHTOA is an acronym for us, and I write it specifically with the O and the H, and the A and the H, and the O and the A in a fraction. Because the large letters here, the S, the C, and the T, those are actual calculator buttons. So the S stands for sine, the C stands for cosine, and the T stands for tangent. And each is a ratio that our calculator figures out. So in order to solve something using the sine button on our calculator, the sine ratio, I need to have my opposite side and my adjacent side. If I'm going to use my cosine ratio, I need to have my adjacent side and my hypotenuse. Tangent is a little different because it doesn't use the hypotenuse, you're going to notice. It's going to take your opposite leg on top of your adjacent leg. So the only two that use the hypotenuse are the cosine and the sine. They use your hypotenuse. So let's take a look at how those would actually work in an example. So if we take a look at example 2A in your notes, we've got a triangle like this, S, T, and R, so triangle RST. This is 19 feet, and I've got 55 degrees. They want us to solve absolutely everything else. So let's name our sides. Across from angle R is going to give me side baby R. Across from angle S is going to give me side baby S. And across from T is going to give me baby T, lowercase t. So we've named our sides. Now we need to label our ratios. So the first one I'm going to do is I'm going to circle my angle. We always get to start by circling the angle they give us or the one they're asking us to find. They gave us one of the angles already. So now I need to label the S, the T, and the R sides according to the opposite adjacent hypotenuse. So you're always going to label the legs next. That is your second step. So, first step, circle the angle. Okay, you're going to circle the angle. Second step, you're going to label your legs. Okay, so label the sides of your triangle. Third step, use one of the trig ratios. Four, you're going to solve and include your units in the answer. Okay, so let's take a little bit more in-depth view of this. If I take a look at side angle T, across from you is always the opposite. So that is my opposite side. T is my opposite side. Across from my 90 degrees is always going to be my hypotenuse. So side S is my hypotenuse. And that must leave our adjacent, which is between our angle 90 and our angle 55. So this is our adjacent side. Okay. Now, they didn't indicate which one to start with. So that means we pick on our own. So I'm going to start with the adjacent side. What that means is you can only solve for one side at a time. So I'm going to cover up the side that I don't need. Now, you always need two numbers out of 3 to solve one of the other unknowns on a triangle. So that means I need to use the 55 degrees and I need to use the 19 because those are the two original numbers in the question. Because I need to use those, I'm going to cover up the hypotenuse and not use it if I'm solving for the adjacent side, and then vice versa. So I'm going to solve for the adjacent. I'm covering up our hypotenuse. That means I've got my O leg and my A leg. I need to use my tangent. So I write my equation. The equation looks like this. Tan of my angle is equal to my opposite over adjacent, because that's our TOA. So my opposite is 19, my adjacent is A beside R. We don't know how big R is. So when we get this situation, we need to remember that it's basically a cross multiply and divide situation. So if I do that, that means this left-hand side is over 1. And I'm going to take my 19 and I'm going to multiply it by the 1, and then I'm going to divide by tan 55. We learned in class there's a shorter step instead of the cross multiply and divide. We learned that if we just took, that would mean that my final answer would be 19 divided by tan 55 degrees. An easier step is going to be to switch the tan 55 with the R, because essentially that's exactly what happened. So whenever you're solving for a number on the bottom of your ratio, on the bottom of the fraction, whenever you're solving for that number, the ratio on the left is going to switch places with what you're finding on the bottom. So that means we're going to divide by tan 55. So we're going to type that into our calculators. And one thing about our calculators, we need to remember it's got to be in degree mode for us to be able to start. So turn your calculators on, hit your mode button beside the second button at the top left of your calculator, and make sure it's in degree mode. Scroll down, select it in black. Next, we go back to our main screen. You're going to type in 19 divide by, now hit your tangent button, and then hit your 55 and enter. That's going to give us exactly 13.3, and we're going to go to 1 decimal place. So it's always best to round to 2 decimal places unless it asks us to, but our next 2 numbers are a 0 and a 3. So this 0, or this 3, pardon me, is not going to make that 0 become a 1. It's not going to increase it. It's just going to stay the same. So our final answer to 2 decimal places would be 13.30. And this one is in feet. So that's feet. So now I know 2 sides of my triangle. We can go up and finish solving for the rest of the triangle. And there's multiple different ways we can do that. First way we can do it is by using Pythagorean theorem. Now that I know the 2 sides, if I redraw my triangle, I know the 2 sides are 19 and 13.3. So I can solve for my hypotenuse by going 19 squared plus 13.3 squared, and then square rooting my answer. The other way to do it, again, is to use trigonometry. So if I use one of my other trig ratios, we need to use the sides that are labeled. So this time, again, I'm looking at my 55 and my 19, because you're always going to start with the sides they give you. And then I'm going to find what side my h is. That's the other number I need to find. So now I've got my opposite sides and my hypotenuse. If I need to use my opposite side, my hypotenuse, that's my sine. So again, I'm going to write my equation. I'm going to write sine, and right next to the word sine is going to be my angle, 55 degrees. Equals, I'm going to put my opposite side, which is 19. It's going to go on the top of the equation this time. And my hypotenuse is going to go on the bottom. So same thing as last time. We're solving for something on the bottom of your equation. So remember our quick trick. Those will switch places. And then we're going to divide. So in your calculator, you're going to take 19 and divide by sine 55. And this is going to give you a hypotenuse of 23.19. And again, that's feet. There's one last thing we have to solve on our triangle. So now we've found the hypotenuse, we can label him 23.19. There's a 0 at the end of this guy. And again, those are all in feet. We know this angle is 55. Remember, we can find the other missing angle. If we know 2 of them, we subtract from 180, or just subtract the 1 from 90. So if I take 55, and I take 90 and subtract that 55, I'm going to get a 35-degree angle. So our missing angle there is going to be 35 degrees. So that means angle R. I can go over to my big object now. My big diagram, I can label hit 35 degrees. My adjacent side I found was 13.30. And again, my hypotenuse I just found was 23.19. There's your first example of solving a right triangle. Try the next side. We're going to try B. B is a little different because this time we're not going to be solving for a side. We're going to be solving for one side of the hypotenuse. But we need to solve for the other two angles. So this is the equation we use. And we do our substitution into the equation using an angle. The angle will always sit beside the sine, the cos, or the tangent ratio, meaning those buttons. So on the left-hand side, the equal sign. However, if we don't know the angle and we're looking for the angle, we need to solve for it a different way. There's only one extra button we need to push. So let's take a look at question B. Our right triangle is D, E, and F. D to E is 26 meters. E to F is 22 meters. Now, if I want to solve one of my acute angles, my D or my F, I circle one of them. It doesn't matter who I start with. I'm just going to start with my D. And you label it according to the one I just circled. So across from it is my opposite. And underneath it, beside, is my adjacent. The adjacent, remember, is between the acute angle you're looking for and the 90 degrees. So, since I've got my O and my A, I go back to my SOHCAHTOA and I look at my phrase, and I'm going to be using O and A. Well, O and A is TOA. So I'm going to write my equation now. Tan, but this time I don't have an angle. So that's going to be tan of angle D. I don't know what D is. And now I'm going to write my equation on the right-hand side. I'm going to fill in my fraction, and it's going to have a number on top and the bottom this time. So my opposite side is 22, my adjacent side is 26. So when I solve an angle like this, there's only one button I need to hit that is different than before. I need to hit my second button. So that's why I always write a little second sign right above it. So you're going to hit second, then your tan button. And then you're going to literally type in the digits on the equation here, on the fraction, and divide them and hit enter. So, second tan, 22 divided by 26. That's going to give us angle D is 40 degrees. We get 40 decimal 2, 3, 6, etc. It runs on forever. But when we're solving for angles, we typically round to the nearest degree, unless it tells us otherwise. So that means angle D is 40 degrees. So now I can go to my diagram. I know D is 40 degrees. I can easily find F by subtracting from 90. So, because this guy here is also a 90 and 90, and my 90 give me 180 degrees total. So, to find angle F, I'm going to take 90 and subtract 40 to give us 50. So angle F is 50 degrees. We only have one last thing on our triangle to solve for now, and that is side baby E, which is our hypotenuse. We need to solve for our hypotenuse. And again, there's two different ways we can do it. We can use doing Pythagorean theorem, a squared plus b squared equals c squared. We're solving our hypotenuse, or we can use one of our SOHCAHTOA tangent, sine, or cosine ratios. So all you do literally is pick whichever way you find most comfortable and that you find the easiest. I'm going to use one of the SOHCAHTOA ratios just to show you how it would work. So that means I'm going to circle one of my angles again. I'm going to highlight it for you. I'm going to use the one that I found first, my 40 degrees. And this time I'm going to use my opposite, and I'm going to use my hypotenuse. You always have to use two numbers to look for an unknown third number. So, opposite and hypotenuse is going to give me my SO, which is my sine ratio. So again, you write sine next to your angle. 40 degrees is the one I have circled. equals my opposite side, which is 22, over the hypotenuse, which is letter E. We don't know how big our hypotenuse is. So in this case, we're going to now switch sine 40 and the E, they're going to switch places. So sine E, our hypotenuse, is going to be equal to 22 dividing by sine 40. And again, it's the sides, we're going to go to 2 decimal places. We're going to get 34.23. And our units here in this case were meters. Don't forget your units. So that's how we start when we have 2 sides and no other angles than our 90-degree angle. So we can start by solving one of the other angles and then continue solving our triangle from there. The only other thing we need to remember from trigonometry then is a little bit of problem solving. So if we take a look at one of the problem solving questions, number 7, we're going to draw the question out. That's our first instinct when we have a question and it's in word format. We need to draw the diagram. So if we turn to page 3, number 7, we see the question that says one of Canada's tallest trees is a Douglas fir on Vancouver Island. The tree is 93 meters tall. So here's our tree, and it's 93 meters tall. And then it tells us if, when you look at the top of the tree, you're looking up at a 50-degree angle. So we're standing here, we're looking up at the top of the tree, and we're looking at it at a 50-degree angle. So we've got our 2 parts of our tree diagram now. So again, you make it into a triangle, always, always. Or you can start with a generic triangle and draw the parts to it. So now it says, how far are you standing from the tree to the nearest meter? So again, you label your triangle. What am I looking for? I'm finding out how far am I standing from the tree. So this is my x. So again, they're giving us angle is 50. We circle our angle, and we label the sides according to the angle. The height of the tree would be our opposite side. The angle, the side we're looking for between the angle and the 90 is going to be our adjacent side. So I've got my opposite and adjacent. I'm going to use my tangent ratio. I'm going to use TOA. So in order to do that, I start writing my tan. And you write your angle next to it if you have it. 50 degrees. Equals opposite on top, 93, over adjacent on the bottom, x. Again, we're in a situation where we're going to be dividing. They switch places. So x will be equal to 93 divided by tan 50. And this time they want it to the nearest tenth of a meter. So you're going to get, to the nearest meter. So you're going to get x equals 78 meters. So now we found out how far he's standing from the base of the tree. The other situation we could find is if we are trying to find another side, but in this time we're going to be multiplying. So what we need to find is, let's take a look at question 9. Let's take a look at question 9. So page 4, number 9 is going to be our example of multiplying versus dividing in our equation. So again, it's a word problem. We start by, first of all, drawing a triangle. There's our right triangle. Now we're going to label everything we need on our triangle. It says a ladder is leaning against a wall. So this must be our wall, and this is going to be our ladder. Whenever they tell you something's leaning against a wall, it's talking about the diagonal side. So a 60-foot ladder, that means that the ladder here is 60 feet. And it says it makes a 15-degree angle with the wall. And that means the top of the ladder makes a 15-degree angle with the wall, meaning that is this angle right here. So that's 15 degrees. Okay, we need to be able to find out how tall or how high up the wall does the ladder reach. So here's our big wall. We want to find out how far up the wall he reaches. That's our x. So again, we circle our angle to start, and we label our sides. Our cross from our 90 is always the easiest to find. There's our hypotenuse. And on the left-hand side, between the angle attached and the 90 is going to be your adjacent side. So with adjacent and hypotenuse, I've got my cosine. So I'll write my equation. Cos of my angle, 15 degrees, equals adjacent side on top of hypotenuse. And in this case, now my x is on top. My unknown is on top of my equation. That means I need to take the number from the bottom and I'm going to multiply it off to the other side to solve for x. Now to enter it in the calculator, you need to do it a specific way, unless you're specific with your brackets. So we always like to take the bottom number off of the equation and multiply it first to the front. So in your calculator, you're going to type 60 times cos 15, enter. And that's exactly what you're going to type in. And that's going to give us 57.9555, and it wants it rounded to the nearest tenth of a foot. Well, if I take a look, it wants me to round that number, which means I need to look at the number right after it. Well, the 5 is going to make the 9 round up plus 1. Well, adding 1 to a 9 makes 10, which means I'm going to add 1 to my 7. So that's going to give me an even 58 feet. Okay? So we've now found that x is equal to 58 feet. That's how far up the wall the ladder is leaning. So those are the 3 situations you're going to find. Solving an angle when only given the sides, or you're going to be solving for an unknown side, depending on which side and angle they give you. So you're either going to be in a multiplying situation like the one we just did, or you'll be in a divided question like we've done on previous questions like these. Okay? The only other 2 concepts you need to understand, and that's for problem solving, and the one of them is, right now, the difference between angle of elevation and angle of depression. Angle of elevation is always from the ground or a flat surface up and then going up. So, in an example, my triangle is here, and I were to say this is angle A and this is angle B. The one that is the angle of elevation from a flat line from the ground would be going from the ground up. That's our angle of elevation. Now, the next one is called angle of depression. And again, the same as angle of elevation, it must be from a flat surface, meaning any horizontal surface. Same as up here, a flat surface meaning horizontal. And then it's going to go down. Then it goes down. So if we take a look at the diagram that we have drawn already, the angle of depression, if I were to draw it on this triangle, I would need to draw another flat surface at the top, show my flat surface, and then I would draw from my flat surface down. That is going to be my angle of depression. Now there's a really interesting concept that angle of elevation is always equal to the angle of depression. Always, always. So if they give you a question and they tell you the angle of depression, but you need to label the angle of elevation on your diagram, they're identical, so you're able to do so. For example, you could get a question about a submarine or a helicopter. So if I've got an example about a submarine, here's my water surface. My submarine's going to descend from the water, from the top of the water down. Okay, my submarine is going to descend from the surface of the water down deeper in the water, okay? So here's my submarine object. Okay, I can't draw, don't worry about my drawing. That's my submarine. So we need to create a triangle always. So if you created a triangle, a lot of the questions are going to ask you, what is the vertical depth? They might ask you this. That is our vertical depth. Okay, this would be our vertical depth right here. The path of the submarine would be this, the path of our submarine. Okay, there's the path of the submarine. Now, if it tells you the angle of depression of the submarine, they're telling you this angle right here, from the surface of the water down, the angle that the submarine descended on. So that's our angle of depression right there. Well, that's going to be equal to the angle of elevation. Okay, they're always identical. This concludes Unit 3, Trigonometry Review.